The axiomatic systems. The axiomatic system has three basic components. We have the definition, the axioms or postulates, and the rules of logical reasoning. With this, we can make a body of knowledge by deriving conclusions that we call theorems. In terms of definitions, there are terms that we call primitive terms. Suppose we define the word set. So what is a set? It is a group of things. So what is a group of things? It is a collection of things. What is a collection of things? It is a batch of things. And what is a batch? It is a series of things. Now we can observe that we're going around the circle simply because the listed words in our vocabulary are finite. We're bounded with words to define terms. So, what we do is, to avoid this, we take some words as primitive terms or undefined terms. We just take few words that are basic, that anyone will readily understand it without any room of confusion. With those definitions, we can create an axioms. Axioms are also called as postulates. They are self-evident truth. They are the statement assumed to be true without any proof. We can think of them as a laws or a beliefs. We may argue their reasons, but within the system, the assumption is they are always true. Then we also have the rules of inference. There are rules that govern logical reasoning. There are rules for negations, rules for conditionals, rules for conjunction, rules for disjunction. There are so many rules. So, let's have an example. Take for instance, we have the undefined terms point and line. So, there are three axioms there. First is each line is a set of 2 points. Next, each point is contained by precisely 2 lines. And lastly, 2 distinct lines which intersect do so in exactly 1 point. So, let's try to prove it using a model. Our first model is a triangle. So, point here, point there, point there. Let's see if it satisfies the 3 axioms. So the first axiom states that each line is a set of 2 points. Then suppose this is line A, and we can see that there are 2 points at line A, same with line B and line C. Now, each point is contained by precisely 2 lines. We can see that line A and line B is at 1 point, intersecting at 1 point, and also with line B and line C. Line A and line C also intersect at 1 point. The last action is 2 distinct lines which intersect do so is in exactly 1 point. So we can see that line A and line B is at 1 point, and so with the other lines. So let's have another model. Let's take a rectangle. So point here, point there, point there. So let's try to prove if it satisfies also the 3 axioms. Each line is a set of 2 points. So let's take line A. Yes, we can see that there are 2 points at line A, also with line B, line C, and line D. Then next, each point is contained by precisely 2 lines. We can see that the point above line A contains line A and line D, also with the other. And lastly, 2 distinct lines which intersects do so in exactly 1 point. So we can also see that line A and line B intersect at 1 point, also with line A and line B, and of course line D and line C intersect at one point, and line B and line C also intersect at one point. Therefore, this model also satisfies the three axioms. Now we can use two models at these axioms, and we call them as non-categorical. If the axioms only use one model, we can say that it is categorical. But since these axioms uses two models, we can call it as non-categorical.